Okay, thank you very much. I'm delighted to be here. Thank you for welcoming me. Given what Nick just said, I actually think this is not a bad fit. This is a bit of a smorgasbord of ideas, but then so is our field. And what I'm trying to do here is make sense of big data, big urban data, smart city technology, big data science and analytics as applied to cities. And all those things are really quite different with different challenges. I think the starting point in pulling this slide set together and talk together was a number of reflections. One is I've been to many talks where I've seen very interesting, fascinating, intriguing graphics, visualizations. You especially see these at geography conferences. And you're left feeling the future is here, and where do I fit in, and this is where cities are going. And then when you ask the question to yourself or to the presenter, what does this mean? What is the science underlying this? What is the so what? There's often very shallow, very thin veneer of meaning to what we do currently with big urban data. On the other hand, last week I was on the judging panel for the World Green Building Council for Asia Pacific, and we rated and judged some unbelievably fantastic green schemes. Most of which were held together by big data at the building scale. So big data at the building scale definitely is now delivering. Big data, big urban data, technology, and urban services. I think we have an Uber representative here. I sat opposite him at breakfast this morning. Uber Tech is definitely delivering in creating markets where markets did not exist, in shareable urban resources. My own particular research interest at the moment is urban health, and I quite openly and honestly present this as a question mark, as one of those areas where, in principle, big data should make a lot of difference and should affect the way cities track into the future. Quite how that is done is not so clear as the Uber question, the smart building question. So one of the things I want to leave you with in terms of provocation is what is the role for government? What is the role for collective action in using big data to make things different? So what does the future hold for cities? This quote is attributed to Lincoln, as well as other people. You cannot, well, the best way to predict the future is to create it. Another version goes, you can't predict, so therefore create it. You can only create the future, you can't predict it. But a former friend of mine, I've just not met him for a long time, was once a friend, Paul Ormerod, delightful economist and a very comedic person, wrote this book, Why Most Things Fail. He also wrote Butterfly Economics and some other books you've probably read, showing that even the best made plans fail for all sorts of reasons, mainly to do with the illusion of central control and complete knowledge. So we can't predict the future, but we can create it, and people in my faculty of architecture, urban design like to create the future very inventively. But we know that most of our inventions of the future will fail. Where does that leave us? One thing we do know about the future of cities is that cities will grow. They'll continue to grow. These are curves showing the urban growth over the last 500 years. We know that some of these curves are flattening off, not exactly flattening, that's the wrong term. They're not quite as vertical as they used to be, but the world and urbanization is really only going in one direction at the moment, and the question is not will that reverse. It may do if there's some catastrophe, but if things carry on as they are, it's a matter of where they peak and when they peak. So urban population will continue to grow. The population in cities grows. So will the size of cities. People will continue to concentrate. This is because urban agglomeration economies are compellingly drawing. The technology drives down transaction costs. That includes travel costs, and there's a long-term secular trend towards reduction of travel costs. When the horse and carriage was invented, people could travel further. When the automobile was invented, people could travel even further. Cities spread, cities get big. The commuting distance will soon be almost the size of half of Britain. Lecturers, professors in Paris universities commute up from the south of France, etc. Information technology also increases the draw of the centripetal forces. So with higher tech, you get lowering transaction costs. This increases urban agglomeration economies, the centripetal forces, and technology reduces the effect of the friction of distance and the centrifugal forces. We can predict that cities will get bigger. So the urban future, one way regarded, is rather like this. This is 8,000 years population rather than 500 years. And the trend is completely vertical in the last 200 years. Much has been written on the idea of the singularity. Futurologists talk about the singularity as the coming together of the artificial intelligence and human, the technology and the human. Ray Kurzweil predicted that this would happen in a serious way by 2045. It would be difficult to distinguish between who was a pure human, if you like, and who was an enhanced human. The urbanization singularity is definitely coming. Some predict that world's urbanization will approach 100% in 2070s. That's not necessarily all people living in cities, but all people engaged in the commercialized, non-subsistence economy, with those left in the countryside providing food to sustain cities. Looked at over the entire history of the modern human, it is a step function. For most of our history as modern humans, we existed at virtually zero urbanization, and then over a period of 200 or 300 years, actually starting with the end of the Iron Age, we increased from virtually zero to virtually 100%. This will inevitably bring a future of densification, high-density cities, agglomeration, megacities, and therefore regulation. And this is where smart and data comes in, and we can predict that advantage will be taken of technology because we will be living in denser cities. So what? We live in bigger, denser cities. Well, those of you who are following the fascinating work of Louis Battencourt, used to be at Santa Fe Institute for Complexity, now at UChicago, Mansueto Urban Institute, will know that there is a regularity in the way negative and positive externalities scale with city size. If cities are going to grow ever more large and dense, there will be more urban problems. And they will rise non-linearly with urban size. Battencourt and others have shown that there's a remarkable consistency in this non-linearity. If you plot a log model of log population against log of just about any negative or positive externality you want, this is GDP, you'll find a superlinear scaling across the log-log plot of about 13%. So city increases by a factor, GDP tends to increase by 13%. Increase the city size by a factor, crime rates increase by about 13% above linear. Good things and bad things happen when cities get larger. Interestingly enough, the same analytics has shown that scale economies on urban infrastructure that support cities also scale at roughly 13% below unity, so a beta of 0.87, so that the cost of providing roads or the amount of roads required increases by less than unity as a city population grows. There are scale economies. Putting these two together is another way of saying this is why cities will continue to grow. They'll always outperform, large cities will always outperform small cities, both in terms of what they deliver, patents, inventions, GDP, income, coffee shops, and they'll always outperform smaller cities in terms of the average costs of infrastructure. Take a look also at the work of Taylor Shelton, who's plotted these things together, the negative and the positive. And look at Battencourt's work in Nature and Science. We did our own, some of our own work at Hong Kong U Urban Lab, threw up something very similar in a study that's about to be published in Lancet Planetary Health. This is, excuse me, this is 9 urban clusters in the UK, and it's a plot of the odds of type 2 diabetes against the density of fast food outlets. This comes from the UK Biobank study managed at Oxford University Medical School. We're partners with them in building built environment metrics into that flagship national health study. Just look at the blue on the left, that's London. The lowest column on the left of that blue stack is the odds of type 2 diabetes in the lowest quintile of the quintiled fast food outlets in London. As you move to the second quintile, the odds shoot up by about 50%. You're 50% more likely to have type 2 diabetes in a more dense neighbourhood, dense in terms of fast food outlets, and so on and so forth. But the thing I wanted to point out here is that the effects are very much higher in London than the other cities. This is because of density. By the way, the models are controlled for gender, income, heart disease, and everything else you might want to control for. The fast food outlet density per person is roughly the same across all these cities. So in terms of probability of being served, it's equal across the cities. The fast food market is very, very mature, almost saturated. But in London, where people live at higher densities, the spatial availability, accessibility of people to fast food outlets is much greater, significantly greater, because you live closer to people and there are more outlets serving those more people. So you have bigger choice. And this proves to be highly correlated with type 2 diabetes, controlling for all those other things. It's a negative externality of high-density cities. This is why we need smart technology, smart government, because these problems will not go away. They will increase, however much we like to think we've controlled it. Just take a look at this.
The year is 2030. 6 out of 10 people in the world now live in cities, and some are predicting 100% urbanization by 2070. Cities are growing inexorably. The benefits of the city, trade, culture, and the promise of wealth make the cramped living conditions bearable, at least for a while. But with increasing population density has come limits. At first they were, as you might imagine, diseases spread quickly, so as with battery hens we pumped antibiotics through the ventilation systems to keep the population healthy. Architects have made the crowding more bearable. But there's only so far you can go in designing small spaces for human beings. Many of the rich live in pods, no bigger than 2 meters cubed, whilst the poor live in what, from their emergence in Hong Kong earlier in the century, we call cage homes. These are the smallest spaces in which we can physically fit the ventilation, lighting, water and security systems necessary to sustain a human being. And they are vertically stackable too. But how high or deep can we build? 10 years ago, the first 1 kilometer tall building was completed, and some Chinese cities are now housing people underground. But what we didn't expect was the effect density had on our minds. It isn't disease or technology, but our mental health that ultimately limits the human packing density. Without space or light or nature, the human body can survive, albeit in a state compromised by chronic diseases, but the mind grows weak, insular, depressed. Our overcrowded cities are monuments to human power and ingenuity, but as always, over the history of civilization, they push us to the limits and, ironically, threaten to become our undoing.
So what do we do about it, and how should we prepare? Apologies for the darkness, but it's meant to be provocative. The narrative is as long as the history of human society. Utopia has been sought at all stages. Dystopia, panacea, or all healing in Greek, utopian city. But the narratives have changed over time. Currently, smart city is the panacea. Eco-city still on the go. Sponge city is the latest in China, as I'll come back to in a minute. Zero carbon city is compact. Satellite going further back in time, slum-free. Zone city, we of course all know that the zone city was never a panacea. So we cannot predict the future, we cannot invent the future. What do we do? Perhaps smart city technology, big data, provides us a real chance for the first time ever to control, to influence behavior, influence the exchanges and the transactions that make up the city that will push us in the direction of a resilient city. China has 130, I think, sponge cities. These are smart cities directed at a particular environmental issue, which is recycling of water. India has, not so long ago, launched its 100 Smart Cities program and is putting vast amounts of money to support it. It looks very much like, to me, as somebody who actually hit the tail end of the urban cybernetics era, which is why I went into urban planning and urban economics initially in the 1970s. It looks like urban cybernetics has come of age. But the big thing, exciting thing for me is that, well, the urban cybernetics of the 1960s and 70s, which was all about controlling cities as a machine, and therefore failed miserably because you can't. The current technological trend is much better placed to treat the city as a set of self-organizing spontaneous systems and help cities create markets with those things that need better redistribution. Back to that shortly. So smart city components, just a reminder of what these are. They are multiple, from waste to energy to buildings to urban agriculture, smart citizens and smart politics, smart manufacturing, etc. In very many ways, the smart city, urban big data revolution is a bit like the city coming of age in a way that the manufacturing factory came of age 20, 30 years ago. or the office, the smart office, the digital corporation even. The big difference, however, and the recurring theme, is that cities are not under unitary control, and therefore the benefits of smartness and big real-time data will not automatically accrue to cities as they are able to accrue to a factory, for example, where edicts can be given and strategies can be adopted to make use of these use of data in pursuit of corporate objectives. So let's think for just a few minutes on what are we trying to achieve in making cities more successful. I've chosen to couch this in terms of resilience because I snapped up 4 or 5 slides that I gave to a workshop in Berkeley a couple of weeks ago on the issue of resilience. So what sort of urban resilience are we looking for? And given the audience here, what sort of urban resilience is of interest to real estate industry, to urban planners, to city managers, to investors? Well, one type is resilience to linear processes of disruption, processes that make life difficult for us, tricky, introduce risk in terms of investment, introduce risk in terms of moving home, of living. For example, human waste production per capita rises roughly linearly for obvious reasons with the population. This is no great deal, really. We can handle this. We can predict, actually, in this matter, we can predict as long as we can predict population. Also, with these sorts of externalities, it's very common that single agencies can more easily be assigned to managing the risk. The water agency in a city, for example, partly because it is predictable, and therefore you can attract private investment in to take on the risk. The more complex the risk, the more you have to get into PPP type of arrangements, and the more tricky things become. Second type of risk is nonlinear risk, such as the ones that I've just introduced. Problems that rise superlinearly as population cities increase. An example is crimes and health problems that I'll hopefully come onto in just a minute. The non-linearity in these incredibly important urban externalities actually comes from interactions of people. That's why they have usually a log linear, various type of log linear forms, very often in the form of power laws. They can be predicted, but not with a great deal of certainty. They arise from the multiple interactions of many agencies. So attributing responsibility for these is very, very tricky. Then there's another type of risk and resilience issue, which you're all very familiar with as real estate people, cycles. Gordon Brown famously told us all that he had worked out how to overcome the boom and bust cycle in the same breath as selling all our gold at the lowest peak, at the lowest trough of the gold cycle. You cannot avoid cycles. Chinese housing market has already tipped. Hong Kong is tipping at the moment, and there are always tipping points, and there's always booms and busts. You cannot avoid them, but you want to make cities resilient to them, and big data can help, but possibly not as much as with these sorts of problems. And then there is resilience to unpredictable problems, floods, tidal surges, terrorist attacks, earthquakes, regime change, economic collapse, trade wars, real wars, mega infrastructure projects, project failure, etc. Interesting enough, with these sorts of risks, you can often predict the frequency and distribution of risks, but not where they're actually located. With earthquake science, you can predict pretty accurately when the next earthquake of a certain magnitude will happen, but not precisely where. This sort of suggests a slightly different type of approach to resilience planning, one that spreads the risk across the unit of spatial unit of analysis within which the overall prediction is made. And you can think of some city applications along the same sort of lines. So let me move to health resilience. How long have I got left? 10 minutes, okay, thanks. Start with a reference to a lovely experiment, a horrible experiment actually, that I love to mention. This is John Calhoun's population density and social pathology experiment with rats and mice in the 1960s. He was an animal behavioralist. He designed numerous experiments over a 10 or 15-year period. The basic theme was you put lots of rodents in a well-designed rodent city, and you give them sufficient food, bedding, travel, health, antibiotics, etc., and you see what the limits are to population growth. Now, this is a general description of the way this experiment works. The classic experiment was built for 3,000 rodents using all known knowledge about health of rodents. It was a great place to live, to recreate, to bring up families, to exercise, etc. What happened was, over about 200 days, I think, the population grew on a typical S-shaped curve, reached a plateau well below the planning threshold, 2,000, plateaued and then fell off the cliff immediately. This was accompanied by measurable increase in urban negative externalities, behavioral problems, rodent mental health problems, governing reproductive ability is what killed the population in the end. So crowding affecting mental health, affecting reproduction, population fell over the cliff. Now, this was utopian dynamics without law and property rights. We are humans. We have laws and property rights. We can hopefully avoid this. Discuss. We should note also, being an urban planning professor as well, that possibly the length of survival could have been extended with smart urban planning, and the pathology curve could have been reduced. But I suspect, as the experiments show, with all sorts of variants on these, all sorts of variables changed, the same thing happened whenever you got above some sort of critical density. So, 100 years on, what do we know about creating healthy cities? Healthy city issues gave rise to modern urban planning at the end of the 19th century. Once again, 100 plus years on, there's a new revisiting of urban planning by the health professions because of rising endemic health problems in the gigantic growing mass cities of the world. This is Guangzhou's ant tribe. Anybody knows southern China, just over the border from Hong Kong. These are the rural peasants, rural migrants working in factories. They live at, as the film said, densities of at least, or not much more than 2 meters squared per person. And Beijing's mouse tribe, a friend and colleague of mine in MIT, now in USC, documented the almost 2 million urban migrants living in basements, in bomb shelters, actually, under Beijing's tall buildings. Every tall building has a bomb shelter in Beijing. There is a market. The market is so efficient, you can run hedonic models on them, and you can work out the price of the attributes of these underground accommodations. Since I'm running out of time, I'll whiz through these. The urban health theory. I told you I'm skipping all over the place, but I hope you follow the track, really. Just to make the point that 200 years ago, urban health theory was solely focused on the built environment. It was called miasmic theory, miasma coming from bad smell, pollution. It's a Latin word for, or is it Greek? Sorry, for pollution, Latin. And it's malaria comes from that, malaria, bad air. Before the modern era of health studies, cities were thought to be intrinsically unhealthy, and one could catch all manner of diseases, including obesity, from smell. Track 150 years on, the importance of the built environment is to the left, less important to the right. You get a variety of factoring in of built environment. And we're now way back, we're right back with the miasmic position. Built environment is crucial, absolutely critical, only we've learned everything else in between. And that's why one of our labs in the Hong Kong Urban Lab, Healthy High Density Cities Lab, works in partnership with the medical school in Hong Kong U and medical school in Oxford. We've done some work with Cambridge Medical School as well. We're building around the world big urban health data that brings together genetic information, measured bodily function, such as brain scans, built environment, social environment, natural environment. And this is the kind of the medical researchers, and it should also be the urban researchers' holy grail. You have everything. So we have 500,000 people in Britain for which we have gene data, brain scan data, full medical data, history, socioeconomics, social environment, natural environment, air quality, and we've created 700 built environment metrics around the homes of each of these 500,000 people. We can answer just about any health built environment question anybody might be interested in. My question that I'll end on in a few minutes is, what do we do with that? I've got some ideas, but the answer is not quite as clear as Uber, or quite as clear as green buildings, for reasons I've already alluded to. And now we have the modern urban plagues. This is pretty much where we're focused on our research. They're sedentary, they're urban. These are problems. We're doing some work in Dhaka, Bangladesh. Obesity is a big problem in Dhaka. This is not just the developed world. Obesity, mental health, respiratory, cardiovascular, diabetes. And of course, we all know where these come from. I couldn't resist doing that, sorry. So moving swiftly through to the end, this is a month ago now. The Lancet teamed up with Tsinghua University in China to produce the definitive state-of-the-art on healthy city issues and research and policy for China. The interesting thing for people with my sort of interests and yours is that urban planning, real estate, housing was central to this document. Published by the Lancet and some of the smartest medical minds in China. This is a page from the report, translated into English. Urban planning is seen as a key variable for creating healthy, successful cities of the future. We like to think in our particular lab that we're doing what John Snow did 120 years ago, who used manual maps, manual GIS, if you like. We're now bringing together all that we've learnt about spatial analytics, spatial epidemiology, over 100 years of science, and revisiting it with this sort of big urban data set. Let me just show you just a few of the projects that we've been involved in, and then I'll make one or two final comments. This is, put glasses on, residential density and adiposity. That's a posh word for fatness or obesity. We measured obesity using 3 methods: body mass index, waist circumference, and whole body fat, and looked at its association with housing density, and we found these amazing curves, which were published in Lancet Planetary Health earlier this year. Hockey stick curves. The peak in the hockey stick curve is the suburbs, which have become the most popular place to live in modern urban history. Okay. People love what is not good for them. Why do the people like to live in suburbs? Because it's the obvious trade-off between all the attractions of a city on the one hand and land consumption. You want to get as near as you can to urban amenities and choice, and you want to have as much land to consume as possible. That's the balancing act. That's the Alonso and urban economics balancing act. That's why the principal characteristic of cities in the 20th century was and is suburbanization. But it's the very worst area, it's the very worst density at which to live in terms of obesity. I can explain that with some, if you want to ask some Q&A. We're repeating this analysis in China. The Chinese density roughly starts where our curve for Britain finishes on the right-hand side. American densities, urban densities, roughly end where our curve starts on the left-hand side, with two exceptions, very high density neighborhoods in New York and Chicago. So we're working with a big biobank study in China to do the same on the right, and we're looking for partners in the US to do the same on the left, and in that way produce, if you like, a adiposity urban housing density curve that crosses the entire range of contemporary human habitat experience. We've done it with food outlets, as I've mentioned earlier, green spaces. We found a very interesting relationship with green spaces. Basically, we measured green space by NDVI, Normalized Difference Vegetation Index, measured from satellite imagery, so much better than green parks, park databases from local authorities, and correlated this with mental health, serious mental health problems in the UK Biobank. As you move 1 quintile up the Normalized Difference Vegetation Index, 1 quintile up the greenness of a place where you live, the probability of suffering from or of the incidence of serious mental health drops by 5%, which makes a 20% drop right through the range. Urban noise, we're in the process of generating 3-dimensional noise maps of Hong Kong, and then we're going to correlate that with the Hong Kong's equivalent to the Biobank, a study of 40,000 people in Hong Kong, and look at mental health and noise. We've got property values. If anyone's interested in how this relates to property values, it's a whole kind of, if you like, next level of analysis in these studies. We've got property values for each of those 500,000 UK Biobank residents, and we're really excited to move on to the analysis. Walkability, I'll just mention this one last study, I think. So we looked at green parks in London and asked the question, how does proximity to a green park affect the propensity, the odds of walking, either for leisure or for commute? We used the London Travel Demand Survey, 20,000 people, and again, satellite measured green spaces. And we found a couple of really interesting things. One is larger green spaces inhibit walking to commute. Larger green spaces are not necessarily better. Very small green spaces, not effective. Clusters of fairly small green spaces, good for walking. Best urban design, best planning intervention for encouraging healthy travel to work. For retailers and real estate people, clusters of smallish green spaces next to mixed-use developments was the most powerful effect on walking, for reasons you can imagine. One other result, actually it wasn't from this London study, it was from a study in South Wales. We found another lovely non-intuitive result. Urban planners and designers love to intervene to maximize the amount of green space and to minimize the distance between green space and home. It's a normal, it's an obvious assumption to make as a planning doctrine. What we found was that obesity and also cardiovascular disease in elderly people decreased. The relationship was inverted. So the further away to a park, up to a certain distance, the better your health as an elderly person. And if you think about it, the reason is reasonably obvious. Elderly people don't go to parks to play football, generally speaking. They go to parks quite often to sit down. And it's the walking there too that gives them a health benefit. So actually the optimal urban design with respect to parks is to maximize the distance from elderly people quarters to green spaces within a certain limit.